Okay, so here we are talking about rate of reaction. First of all, we will clarify what does rate mean? How do we define it? So rate is a measure. Measure of what? It is a measure of how fast a reaction goes. Basically, we are talking about its speed, right? So how fast a reaction goes, its speed. Then you know how to measure the rate of reaction. So to measure the rate of reaction, we need to carry out the experiment. Okay, to measure the rate of reaction, we need to carry out an experiment, and we will see what type of apparatus we will need to measure the rate of reaction. So here, what we will be doing, we will actually be measure a change. Okay, measure a change when we say what we are referring to. For example, we are referring to a change in mass or, in volume. Also keeping in mind the second point, what is that? Over a period of time. Over a period of time, what does it mean? Means how much gas is produced per minute, per 30 seconds, right? As you know, we are going ahead, we will practice questions and we will see how it is done. For example, here, I give you the reaction of magnesium reacting with hydrochloric acid. Here, let me write the equation so you understand it better. My reactants are magnesium, which is reacting with hydrochloric acid. And the products are going to be magnesium chloride and hydrogen. Whenever metal react with acid, salt and hydrogen is formed. Magnesium, let's put state symbols also. This is solid. HCl, hydrochloric acid, which is aqueous. Magnesium chloride is also aqueous, and hydrogen is a gas. So here, when we look at it, one of the product is gas. Yes, this is what I was talking about. So when one of the product is gas, what we can do here? Let's write it before go ahead with the experiment. One product is gas. So it means I can measure the volume of gas, right? So what I am going to measure, we can measure the change in volume, right? Basically volume of what? Change in volume of the gas over time. What does it mean? Over time means every 30 seconds or per minute. Every 30 seconds, how much gas is produced. So every 30 seconds or per minute. So this is how, we are going to measure rate of reaction. Now, we will talk about the apparatus that we are going to use, to measure the volume of gas in the given time. So yes, here we have the apparatus that we will be using for experiment. As you know, here at the first apparatus that you see, what do we have? Here we have the flask. Yes, in the exam, you will be required to do. It is also called flat bottom flask, round bottom flasks can also be used. Okay, even if you name it flask, it will be fine. This is gas syringe, which is used to measure the volume of gas. Which reaction we are talking about? We are talking about magnesium. This is magnesium ribbon. And here what else we have? We have hydrochloric acid, right? This is hydrochloric acid. As just now we are talking about, and the gas range will measure what? Hydrogen gas to measure this. What is that? This is our stopwatch. Okay, stop clock or stop watch can be used for what? To measure time. To measure the volume of gas, there are two methods which can be used. Number one with the gas syringe, the other one, number two, with measuring cylinder to collect the gas over water. Measuring cylinder. But since you know, hydrogen is a gas which is insoluble in water, so it can be collected over measuring cylinder over water. This is what this is basically water here. This is called water trough apparatus. We will make ourselves very familiar. What is this? This is basically delivery tube. Delivery tube. Here, you know, what do we have? We have magnesium ribbon. And what else? There will be hydrochloric acid as well. So same apparatus, stopwatch can be used. How we will be taking the readings here, you know, measuring cylinder. So what will happen? Water will be going down. It will be displaced as, you know, gas moves up. Gas will be coming from here, right? And similarly here, gas syringe, what it will actually be moving out. So you will be able to read the volume of gas, to note down the volume of gas on the gas syringe. So either method can be used to measure the rate of reaction. So here now we will talk about factors affecting rate of reaction. First factor that we will talk about temperature. So remember, as temperature increases, rate of reaction increases. This thing also we need to explain why. Again, you know, everything comes with why. As temperature increases, rate of reaction increases too. Right now, why? Particles gain kinetic energy. Particles gain kinetic energy. When they gain kinetic energy, what happens? They move faster. So when you know they move faster, what happens? There are more successful collisions. More successful collisions. These are the good keywords to write in the exam. Similarly, of course, as temperature decreases, rate of reaction decreases, and everything will be the opposite of it. As temperature decreases, the rate of reaction decreases. And why do you say that rate of reaction decreases? Because particles lose energy. Particles lose energy. They move slower, and when they move slower, there are less frequent or successful collisions. So these are the keywords, you know, that we will remember for temperature. Now, next factor, we will talk about concentration. How does concentration affect rate of reaction? That also we need to remember that as concentration increases, rate of reaction also increases. Okay, again, you know why rate of reaction also increases. And here, you know, we will talk about that why, you know, it is gonna happen. Okay, when you know concentration increases, what does it mean? Means more solute particles. Okay, more particles of what? You can say more particles of solute or reactant, right? Available to react per unit volume. This is good, you know, to explain. So when you know more particles available to react, what does it mean? More particles available to react, more successful. Less successful will be for less concentration. So more successful collisions and rate of reaction increases. Similarly, when we go As concentration decreases, so everything will be the opposite of it. As concentration decreases, rate of reaction decreases. Okay, and why is this so? Okay, less particles available to react, per unit volume. Make a habit of writing full answer. Okay, so when less particles available to react per unit volume, it means there will be less successful collision, so rate of reaction decreases. Collisions, yes. So these are our answers with all the keywords that we need in the exam. Yeah, do add it. As I say, concentration increases. The rate of reaction also increases. More particles available to react per unit volume, more successful collision. So similarly, when decreases, rate of reaction also decreases, less particles and less successful collision. Okay, so now we will talk about this, which one, surface area of a solid reactant. How does it affect the rate of reaction? So again, we will write the statement first, what it says as. Okay, so basically we can say the greater the surface area, the higher the rate of reaction. Again, how, why? Why is very important to explain in the exam. The higher the rate of reaction. And this is why, because more atoms are exposed. More atoms are exposed to react per unit volume. Per unit volume. That is why, again, you can use this word, more successful collisions and rate of reaction increases. Okay, this is about surface area. We have one more factor that will affect rate of reaction, and what is that? We will talk about it. Surface area we have done. Now, we will talk about catalyst as well. Catalyst, first of all, what is it? It is a substance that speeds up a chemical reaction, and remain unused. This is important. Okay, yeah, so it will remain unused. And how does it increases the rate of reaction? Okay, speed of reaction, catalyst increases the rate of reaction by lowering activation energy. So these are all the keywords that we will require to explain all these terms that we have discussed here. So we have concentration, we have temperature, we have surface area, and we have catalyst too. Yes, so here, we will talk about that how we can plot the results on a graph, because yeah, in the exam, we will be required to do so. So here, on y-axis, what I have volume of hydrogen gas, whatever gas is your product, since we have taken the example of reaction between hydrochloric acid and magnesium. So I'm taking volume of hydrogen on y-axis, and here I will be taking time on x-axis, making sure you are writing the units. Time we are going to take in minutes, and volume of hydrogen in what? In CMQ. We are talking about the reaction that just now we were talking about. Our example was what? Let me quickly remind you about magnesium which was reacting with HCl. Metal react with acid, it forms salt MgCl2 plus hydrogen. So here we are measuring rate of reaction. How? By measuring this volume of gas. So here, what do we have here? We have this volume. So let's put the axis 0, 10. Of course, I'm not drawing according to the scale. When you draw, you will draw according to the scale. Okay, and here what you will have? You will have time, 1 minute, 2 minute. Yeah, choosing the appropriate scale on the graph is also very important. So now here, what you will put your points accordingly, like what you have got. Let me there will be different points that will give you on different minutes, and you will plot your points. I am using the digital pen, so yeah, I'll try to, here I'll have my, because yeah, I need to put the line till the last. So here, this will be this will be our plotting of results. Here could be 6 minutes, 7 minutes. So what is that? This is basically the reaction between magnesium and hydrochloric acid. Here, we can see the slope, the curve. It actually tells us that how fast the reaction goes. Is it? All right, because what does it mean? Here, you can see at the beginning, it is the steepest curve. So it means rate of reaction is the fastest, right? Steepest curve. And what is it referring to? Fastest reaction. Okay, yeah. Then, as we can see, as time passes, it becomes less steeper, right? Okay, so less steeper, what does it mean? It is referring reaction is slowing down. Reaction is slowing down. This is what, in the exam, we have to explain about graphs as well. Then, after that, we see that, it becomes flat. So when, it becomes flat, what does it mean? Reaction has stopped. So at the beginning, it was fast. Then, it was slowing down, and then, finally it stopped. So this is what, we will be interpreting. So here, basically, rate of reaction, what it has become. Here, rate of reaction has become 0, right? Because it is not increasing. So this is how, we will be drawing our graphs and interpreting. This is the example that I have taken for this reaction. We were talking about the hydrogen gas, which was plotted here.